call them Skillarty. Chanda Paul, some me give it to, some me give it to, some me give it to our girls. 5 million and 40 naughty shorty. Baby girl, all my girls, all my girls. Chanda Paul say, well, I'm on the way the time.
Lesson 7-3, our learning intention. I will be able to find the area of trapezoids and kites. Our essential question, how can you find the area of kites and trapezoids? How do you know you're successful today? I can 1, find the area of trapezoids using the formula, and 2, find the area of kites using the formula. All right, Ms. Conrado, take it away.
All right, guys, let's get into our 7-3 notes for today. Our central question is, how can you find the area of trapezoids and kites? So under our academic vocabulary, we're going to be working with how to decompose these two shapes of a trapezoid and a kite. Let's remember that when we decompose, we are pulling things apart into a smaller part. So if we look at this shape, which is a trapezoid, we can see that this shape, if we decompose this shape into familiar shapes that we know, we have 2 triangles on the sides of our trapezoid, and then we have a rectangle on the inside of our trapezoid. When we compose and put all of these things together, all of these shapes, it makes a trapezoid. So a trapezoid is made up of a triangle and the shape of a rectangle. So because we know the area formulas for a triangle and for a rectangle, we can find the area for a trapezoid. Let's remember that an area to find for a rectangle is base times height, and the area formula for a triangle is 1/2 base times height, or base times height divided by 2. And then let's review the shape of the kite. If we look at the shape of a kite, let's decompose or pull apart the kite to see which shapes a kite makes up. So we see that we have 4 small triangles in red. When we compose and put them all together, it makes a kite. But a kite is also made up of 2 large triangles. Both are correct for small triangles or looking at it as 2 large triangles. So because we know the area formula for a triangle, we can find the area of a kite. The area of a triangle is base times height divided by 2. And because there are 2 triangles, we have to find the area for both triangles. We add them together and we get our area of a kite. Let's jump into example number 1. Let's do a couple of examples where we find the area of a trapezoid. So before we go on, let's decompose the other side of the trapezoid. So we have the right side, it has dashed lines, and we have 1 triangle. Let's do the same thing to the other side. So we just did step 1. We drew lines to show the rectangle and the 2 triangles. So we know that the base of just the triangles are 4 centimeters each. We know that all along the base, from corner to corner, it's 20 centimeters. So because we know that one part of the base, the triangle, is 4 centimeters, and the other part is 4 centimeters, let's add those together, which would be 8 centimeters. And let's subtract that from 20 centimeters. And what we have left is 12 centimeters. That is the base for the rectangle. And we know the height for both the triangle and the rectangle is 8 centimeters. So now let's find the areas in step number 2. Let's find the area for the triangle. For a triangle, we have the area formula of base times height divided by 2. Our base for one of the triangles is 4 centimeters times the height, which is 8 centimeters. Let's divide that by 2. 4 times 8 is 32. Divided by 2, that is going to be 16 centimeters squared. That's for just one triangle. Let's find the area of the rectangle. Area of the rectangle formula is just base times height. Base is 12 centimeters and the height is 8 centimeters. 12 times 8 is 96 centimeters squared. And then don't forget that we have one more triangle. So Ms. Flemington is showing you the formula again, but because both triangles are identical, we should get the same area as the first triangle that we solved for. So now we would add these areas up. We're going to add all of them together. 16 centimeters squared plus 96 centimeters squared plus 16 centimeters squared is 128 centimeters squared.
I didn't hear what you said. So
No worries. All right. So let's jump it down to our output page. And let's find the area of this trapezoid. Again, let's decompose both, all shapes that make up a trapezoid. So Ms. Flemington is decomposing the 2 triangles on the side, and then we have a rectangle in the middle. Because both bases are 1 centimeter each, we take that away from 5 centimeters, and our base for a rectangle would be 3 centimeters. We also can verify this because at the very top, we know because these sides are equal since they are parallel to each other, the base is 4 centimeters, and the height that stands straight up and tall is 4 centimeters. So we know our bases and we know our height. So now let's find the area of all pieces. The area of the triangle and the area of the rectangle. Area of a triangle is base times height divided by 2. Our base is 1. Our height is 4 divided by 2. 1 times 4 is 4 divided by 2 is 2 centimeters squared. The area of a rectangle formula is area equals base times height. For our rectangle, the base is 3 and the height is 4. 3 times 4 is 12 centimeters squared. Ms. Flemington is again showing her work to find the area of the second triangle. Because they're identical, it should be the exact same area as the first triangle. Now we add all of our areas together. 2 plus 2 is 4, plus 12 is 16 centimeters squared for this trapezoid. Okay, the next area you guys will do on your own, and we will review it together in class. Don't forget all of your steps to decompose, to find all the areas, and then to add all areas together to find the area of the trapezoid. All right, let's go back to example number 2 now. And now we're going to focus on finding the area of a kite. So again, let's pull apart or decompose the kite into 2 identical triangles. So we're going to be pulling apart or decomposing this kite into 2 triangles. We have our first triangle that's drawn in red and our second triangle that's drawn in blue. The first step is to find the area of the first triangle, and then the second step would be to find the area of the second triangle. So remember, we are going to need to know the base of these triangles and the height of these triangles. So the way that they break it up is that the base is broken into 2 parts. We have 3 inches and 3 inches. Because we're finding the area of the entire upper triangle, left side of the kite, the triangle in red, we need to add these bases together. So we would add 3 plus 3, which is 6. So now we can use that base value to find the area of the entire red triangle. So we know that the base is 6 for both triangles because they share a base. So if we go back now to triangle number 1 that's highlighted in red, if we look at that triangle's height, which is highlighted in green, notice how we don't go all the way down from one corner to the other corner. We stop at the base. So that height is 4. So 6 times 4 divided by 2 now, because we plug it into our formula, is 12 inches squared. That is the area for the triangle in red. So now let's find the area for the triangle in blue. That height of that triangle is 6 inches. So let's plug that in or substitute it into our formula. So 6 times 6 is 36. Then we're going to divide it now by 2. And we get 18 inches squared. So we took one piece of the kite, which is the first triangle in red, and that area is 12 inches squared. Then we took the next triangle in that kite, which is in blue. That area is 18 inches squared. To find the area of the whole kite, we need to add them together. And 12 inches plus 18 inches squared is 30 inches squared. That is the area of the entire kite in total. So let's do a couple more examples. Let's scroll over to our output page and look at quadrant 2. So in this kite, when Kelsey cut pieces of fabric in the shape of kites for a quilt, they want to know what is the area of this piece of fabric. The fabric is flat, so let's find the area. Okay, so Miss Flemington just decomposed her kite into 2 large triangles. We know the area formula for a triangle. The base, they share the same base, which is going to be 6 centimeters for both triangles. Triangle number 1 has a height of 4, and triangle number 2 has a height of 8. We know all of our pieces, so let's substitute them in. Okay, so Miss Flemington just wrote her area formula for triangle 1 specifically, and then triangle 2 specifically. So now let's plug or substitute these values in. Our base, again, they share the same base, which is 6 centimeters. And sorry, we're going to add, because I didn't see that it was split into 2. So 6 plus 6. So all along that entire base is 12 centimeters. So that's our base, is 12. Our height for triangle number 1 is 4 centimeters. We divide that by 2. So first let's multiply 12 times 4, which is 48. Let's divide 48 by 2, which is 24 inches squared. Now let's find the area of the triangle for triangle number 2. The base we know is 12, and the height is 8. We're going to multiply 12 times 8 and divide it by 2. And 12 times 8 is 96. Divided by 2. 96 divided by 2 is 48 inches squared. So now we found the areas of both shapes separately. We have to combine and add them together to find the area of the entire kite. So let's add 24 plus 48. And 24 plus 48 is 72 inches squared. So now in example number 3, go ahead and decompose this kite into 2 large triangles. That's going to be your first step. So you know what triangles you need to find the area for. You're going to find the area of triangle number 1, and then find the area of triangle number 2. Once you find those areas, you're going to add them all together to find the total area of the kite.